All right, folks, so welcome to our second session. This session will be followed with lunch and then will be followed eventually with presentations from all of you. And one final thing, your certificates will be available this week. You'll get a notification of your completion certifications. Code generation. See, we talked about what a language model is or what a sequence to sequence model is. Suppose I have text. Think of text. It goes in and I get a language representation. A language model or a sequence to sequence model, as it is called, will have an encoder, will have a decoder. Are we together? And this, oh, by the way, I must clear one confusion that people keep asking. They keep saying that, see, this is the general construction of a sequence to sequence model with the hidden representation. But people say, hey, GPT, for example, only uses the decoder of the transformer. How do you explain that paradox? In a transformer, there are two pillars, right? The encoder and the decoder pillar. And people say BERT uses only the encoder part, GPT uses only the decoder part of the transformer.
Actually, I encountered that yesterday in one of the YouTube shorts. Explaining that, okay, BERT is using only the encoder and then GPT is only using decoder. But I was surprised.
But then I'm saying that a proper language model needs both.
Yeah, exactly.
So what gives? Should I leave you guys with the paradox or should I answer it?
That is already trained encoder, maybe? Or like it has all the encoders built in? So
I don't know. That's a good guess. With somebody else, what's going on? So either I'm wrong or those guys are those things shouldn't work, but they work.
Yeah, I don't understand the question, but we know GPT has both encoder and decoder.
No. GPT has only the decoder part of the transformer.
So I think
the generator part is
there's the decoder part.
Yeah.
But then what do you generate from? They just generate directly from the prompt.
It's trained using the encoder.
Oh.
There is a pipeline. The client will feed the data, convert that data. Foundation part is that's why we
Okay, how about this? I'll let you guys discuss amongst yourselves. I won't tell you the answer to that. Okay? Some mysteries, it's a pleasure to hold on to them.
Yes. So I think one thing, what I guess is like, okay, because they have that hidden representation, right? And all that is going to be the input for the GPT, so that it may not like the encoding part because it has a.
No, you're off track. Okay, I'll let you guys decipher that. But I'm saying that a language model will have an encoder decoder. Theoretically, this comes up with a hidden representation of the text. H is a hidden representation of the input text, right? Input sequence. Token. It will create a hidden representation. This gets into the decoder and whatever you want comes up. Now, let's think about what are the use cases that it can apply to. So, for example, translation is a common example, isn't it? I could feed in English and I could get Tamil. I think the majority of this class has an unusually high Tamil population. So Tamil is the primary language. Right? Yeah, actually, this is very interesting. You notice that in the US, mainstream US, outside the other side of the Rockies, whenever they talk about foreign languages, it's almost always French, Spanish, and so on and so forth, right? And coming from Asia, you always wonder, most of humanity, the most spoken languages are English, Mandarin, and Indian languages, right? So I think the people on the other side have still not woken up to the fact that those languages belong to minuscule European nations, more and more becoming irrelevant. Okay, well, that's inside. So English to Tamil, let's say. You can do that. But you could also do English to English. Why would you do English to English? Summarization. You can do sentiment analysis too. Yeah. You could say, come up with a word, happy, sad, whatever it is. Summarization. You could convert it to poetry. You could look for contradictions.
Generate a story, how they say.
Continuation, yes, generate. The most common thing, generate content, new content, such as story, essay. In fact, that's the typical use case of chat GPT these days, or there's chat models.
Document style.
What's that?
Style.
Yeah, style transfer. Bullet points. What bullet points it, right? You can extract knowledge graphs from it.
That's interesting.
By the way, this is actually a project that you will do in the subsequent course from it. RAG, when you do LLM2, you will do knowledge graph driven RAG. Right? Then, and many other things you can do. Right? But notice now that people talk of languages, natural languages, and we also talk about programming languages. You know that programming languages have strict schemas, grammar. Isn't it, guys? Programming languages, like for example, SQL, SQL, Java, Python, C++, HTML, JavaScript. Go ahead. And in the programming languages are mushrooming every day. They have a strict structure. Right? They're not so flexible. Natural languages are more permissive, isn't it? And it sort of is illogical. There's a lot of things that you have to infer. Somebody that reminds me of a joke. Some English professor was saying that a double negative makes it positive. Right? I did not do it, means I didn't. Right? But a double positive doesn't make a negative. So in the back, one student just says, yes, immediately contradicting with the tone of the voice. Right? So, well, English language can be any natural language can be pretty more permissive, and many things go into it, the tone, emotion. I tried to learn Mandarin, and every time I would say, I would memorize lots of Mandarin words. It's the one language that I failed at learning. Because every time I would speak to my Asian friends in the office, colleagues in the office, they would just burst out laughing. Because it's a very tonal language. It isn't the word, but you have to say it in the right tonality. Japanese is also like that. Chinese Mandarin is very, very, very tonal. In fact, it's a remarkable fact that there are no tone-deaf people in China. You know, a lot of people here in English-speaking nations, they can't appreciate the tone of a music. They don't catch it at all. Right? Because English is not a tonal language. But apparently there are no tone-deaf people in China at all. Because it's the intonation that makes all the difference to the meaning. Right. So anyway, the point I'm making is a lot goes into an LLM. Now the question comes, from a natural language, can you extract a very logical, structured info that can be written in this XML, even markup languages, LaTeX, text, whatever it is, in any one of these languages. We know that LLMs seem to be able to do that, isn't it? And technically, a language to language model, a sequence to sequence model should be able to do that with enough training. Does that make sense? And that opens the door to something remarkable. Can I ask it to say, let's do a thought experiment. You have a database. It has, let's say, 10K tables, which these days is a very modest scheme, isn't it? New tables spring up in a mature database practically every week. They are tables. So the joke is that between every two tables in an enterprise database, what should exist? An intersection table, AB table. Right? And then let's say that you have another table C, and obviously there should be one intersection table here. And then let's say you have something like this. I'm just joking, but it's not too far from the truth. Sorry, it's not too far from the truth, isn't it, guys? How many of you can speak to it from experience that the reality is like this? Before you know it, your schema begins to look like this: BD, CD, AC. Does that look like real life? And before you know it, there's an intersection table between intersection tables.
Yeah.
Right? It starts getting really weird. Right? So let's just leave it like this. Tables mushroom. You keep it because you want to follow the chord's rules on normal forms, normalized data. You do that. Let's talk relational databases. Does this all look very familiar territory, guys? And yet, when we ask this question, let's say that imagine a grocery store chain, Safeway, right? A chain of grocery stores, and you ask a logical question. In winter, which was the most revenue generating produce? Isn't that a basic question? But today what would happen is you would say, okay, let's get that answer. Let's talk to our data analysts. They will say, yes, we can answer it in one sprint. 2 weeks later, right? They would come up with a SQL query that is mile long, that does inner join between just about every bizarre combinations of these tables, and then comes out with the answer and assures you that during winter, God knows which produce. Let's say potatoes were the biggest revenue generator, right? Or avocados were the biggest revenue generator in your system. It's a simple question with a simple answer. But to do that, you had to do this very complicated SQL. So now, why cannot, why can I not take this question? Let's take this question. Which produce generated the largest revenue this winter? Implicit is across all the stores. This is a natural language question, isn't it, guys? It admits a simple answer. Let's say avocado. What prevents? Theoretically, it is you can build a sequence to sequence model to do this. And so people have, for the last many, many years, tried to create language generators. So what is the in-between stage? You can't say avocado. The machine doesn't know. The in-between stages, you have to actually go from here to SQL, which you will fire against a database, which will produce avocado. Right? So you realize that you need the database to look the data for. So what you really need to do is a sequence to sequence model from natural language to SQL. A sequence to sequence model, isn't it? Does that make sense, guys? Now the question is, how can it produce a SQL? Think about it this way. The English language does not have the necessary information to write the SQL. Does it have? No, because it completely depends on what? Your database schema. The structure of your database determines what is appropriate or valid SQL for this question. Are we getting it? So now comes the question, what can we do? Perhaps you say, well, what if we could augment this question? Let me just call this question plus schema. I gave it the entire schema definition of the tables, right? Described all the tables. And this became my prompt. This goes into an LLM. And then the LLM can come back with the SQL, which I can fire and then come back with avocado. Does this make sense, guys? Mm-hmm. So when you take a prompt and you generate, so this process is the generation. This is the generative process, right? What have you taken the prompt and done what to the prompt? You have augmented the prompt with schema. So this is a good example of it would come within the class of, let's say, RAG, isn't it? Right? You could go into your search index, get the schema associated with this query, right? We're talking about produce so you can get the entire schema definition, feed it in, and feed it into an LLM and generate the SQL. Are we together? Has it been done? Yes, it has been with great success. In fact, it is my pleasure to tell you that one of the most successful implementations and large-scale implementations of this SQL generation actually came out of that room there. It was your previous cohort. Came from your previous cohort. That team worked for Cloudera. Right? They, as we speak, I think last week or this week, they're releasing the product officially. They have already presented it at the ApacheCon conference to a standing ovation. Right? There is a benchmark in databases called TPC, data science. Database world has its own benchmark. Made up of some really bizarre, complicated queries of 92 or so queries. These guys started with this idea. They literally came to a course here. They did that. In the duration of this bootcamp itself, they started on that problem. We had done this course slightly differently. We had done code generation early on in that version of the bootcamp, and they went at it, and they put a tremendous amount of hard work. I wouldn't take all credit. Our job was just to ignite the fire. After that, they took off. They worked very hard at it. And now, I think they call it Smart SQL or something. So imagine that you can go to a big data store, give natural language query, and get your answers.
So just to understand the process, the schema is still designed manually?
Schema is always designed. There are tools that will take any database and extract the schema definition out of it. Schema is metadata. There are tools to extract metadata from any database. If it is laid out relationally, the database server will give you the schema.
What if it's not database?
For example, if it is Mongo, it will give you the Mongo catalog structure. So it works for, I'm just giving you one particular example. So this is real, guys. This is very real. Yeah. And it's really nice to have been a part of that journey. at least getting those guys started. But those are bright guys. They literally were in that room and they produced that. I'm still waiting for great things to come out of you guys. Tell me your success stories when they happen. So
Did they do it? There's basically one is you said something the RAG, R part, where you pick up the schema. But then why is the if you're doing that, why is the again the G part needed? What is that?
generation is the SQL generation, right? You need to generate the SQL.
Oh, so the R part is only
The retrieval. R is just the fetching the schema.
only the schema. Okay, okay.
That's right. Yeah. So guys, it works. And in fact, you will do that today as part of your assignment. Do it in class. The whole afternoon, you'll be pleasantly surprised how easy it has become. Okay. Go ahead, Prasanna.
Did you do it as part of LLM 2 or what?
One, LLM 1.
Wow.
They came to LLM 2 and they learned more techniques, but they started on it when they were still doing LLM 1. Yes. So again, a lot of successes actually. That room obviously did amazing work, which has a high impact on the industry. How many companies are you? They are the leading big data providers, and imagine the tens of thousands of clients that they have. Startup came from this room. Startup came from that room, right? Startup came from that. Vector Smiths. I hope you guys are going to do your startup. Your predecessors had their startup. Okay. So good success, actually, good success. So anyway, today's topic therefore is, you realize that if you can do it with SQL, you can do it with anything, right? You could take natural language and you could convert it to Python. You could convert it to React JS code. And in fact, it is so. Now, we are hardly surprised. Just go to any of your chatbots and say, I want to write a little application. Give me the UI. It will generate HTML, CSS, and JavaScript code all for you. This is just the beginning of things. When you do the agentic reasoning course with me, those of you who will do it, you'll realize that actually it has become, for most situations, foolish to sit and code. Because with multi-agent, multi-AI collaboration, high quality code, much higher quality code than you can write, is written by the machines in a couple of seconds. And they debate and make sure that the code is right. And if the code has a bug, they automatically go debug and fix it. I'm not kidding. You'll do that.
From the training
You can train an agent to look up the documentation of the library, to figure out what is not working, debug it, fix the code, and then continue on this.
we need that for on-call support so that we can sleep peacefully.
On-call support. Prasanna mentioned on-call. So I'll give you an example. By the way, I'm just trying to tell you stories from the previous cohort. For the LLM2, one day I taught this. Immediately within the class, in the lunch hour, one cohort member sat down, took the Jira tickets, the issues that come, support tickets that come, ran multi-agent, the collaboration, agentic collaboration, and in one fell swoop, from the issue, it had pulled up the code base, identified the bug in the code, fixed the bug, tested the bug, and by evening had fixed, and I'm not exaggerating, 6 bugs were fixed. 6 customer service issues were resolved that were outstanding for the last couple of months.
Wow.
Literally. And you will learn those techniques, I promise you. This is just see guys, in this course, I've taught you a little bit of everything, but you haven't gone deep. Now would be the time to go deep.
There was the same team who did the SQL generation.
What's that?
I'm just saying that
Yes.
was the same team.
It was the same team
Same
that
team.
did the SQL generation. And by the way, we are not talking about some trivial bug, changing. They really took it forward. They demoed the first issue being fixed, and by the time they were done in the evening, 6 issues were fixed.
So I was wondering how this model is trained to prepare. So something said like SQL generation. What type of training?
Do it. Bhavin, do it. That's your lab. Now I come to the lab. Right? So why speculate when we can do? Right? So guys, I hope
So can I share a story?
Yeah, sure, please do.
So this is Sarah LaFleur. I work for Solution Stream, and we train all of our engineers, and this is from Asa's work because I didn't know what to call it until he introduced it, to be intelligent engineers. And 80% of all the code that's written is written by AI assistants. And everything that they produce is done in that fashion, from infrastructure, Docker files, Kubernetes, database schema, back end, front end, full API. One good example is we did a greenfield project for the Senate, which would normally take about 3 or 4 months to produce. So full back end, infrastructure, front end, complex system. We did it in 4 weeks.
Wow, amazing.
With that ability. So it's Asa's not kidding when he says you're just touching the surface. And even in all the things that we've been doing, we're still learning how to go faster.
Yeah, thanks, Sarah, for sharing that. This is the new world.
One thing, actually, one thing I found was depends on the level of security you want to bring. That's sort of where we have to be some.
See, developer world is not secure, right? In the sense that you're sitting there trying to find a solution. Once the solution is there, then you can do a security inspection. But the code generation is like, when a developer sits and writes code, we first ask him to solve the problem.
Yeah.
Then we bring in security scans.
No, sorry, what I meant as it depends on, like, for example, secure coding practices. I'm not sure.
LLMs do far better secure coding than you do. Trust me. Absolutely.
That seems quite obvious that LLMs can do better than us.
Oh, far better.
It's like,
see, guys, I'll tell you, I use Copilot and all of this. So I've trained a model. It has picked up my programming style. Right? Now, those of you who have seen me code, you know that I'm quite a sort of stringent about coding style, right? There's a particular way I write code, documentation, everything in the code. The more production code, not the sample codes that I've given you. And it has picked up on that style. And suppose a code is checked in, it can immediately sense that I didn't write it in the project, and it goes and changes it to my form of coding. And it actually identifies all the security holes and points it out.
GitHub Copilot?
No, it is a model that we have trained.
Oh.
In-house model.
I'm in GitHub Copilot.
So it is amazing, guys. So today what you will do, I hope that's sufficient inspiration. You will go and do a simple exercise, which is here. You will get a grocery store, the same I talked about a grocery store for a reason. You will take a simple grocery store whose schema is here, import it into MySQL, MariaDB, whichever flavor, right? Or into Postgres, whatever you like. Then extract from that, the moment you ask it, relational databases will tell you the schema. They'll generate the DDL. Do we understand DDL? Data definition language. It will generate the DDL. Then use RAG, for example, you can use Llama Index, whatever you want, and then use Chainlit or something of your choice to create a chatbot to interrogate the data. This is your full version of the project. You can keep doing it over the next few days. But in the meanwhile, so there are a few goals. For each query, the response should be SQL queries needed to retrieve the answer. The result actually should be result in HTML table form. We should generate the HTML also. And here are a few stretch goals for you to do. Use the LLM to generate the Python fast API microservice. You'll need a microservice for this, UI. They call it your data interrogator. Anybody has read Brothers Karamazov? Okay. There's a lovely chapter there called The Grand Inquisitor. So let's borrow from that. Create your Grand Inquisitor. It will interrogate the database and come back with answers. that UI, obviously you need what do you need? You need a UI, you need a microservice, and you need the SQL generation and so forth. So do all of that if you can. Use the LLM to generate your HTML, React, JS front end to your application. And in the beginning, just use Chainlit or use whatever you want. Use agentic. Oh, this part you can't do because you're not yet trained in agentic reasoning. I've just left it as a stretch goal. Someday you'll do it. Are we together? Right. Now, here is something I'll tell you. This is the assignment for you to do in the next few days. But for the time being, what I would encourage you to do is go look at these three projects, Vana, Data Herald, and SQL Coder. In particular, Vana. Use Vana. Vana is a pre-built solution for everything that we just said. It is built. You just have to use this open source project. So guys, do you realize that if you use Vana, just point it to your database and it can answer your questions. I want you to do it this afternoon. Is that fair game?
Just set up this
That is it.
code and just run it.
That is it. That is it. And you start. And so, did I ever mention that your software development jobs are history? Yeah. So, no, I'm kidding. So, yeah, go ahead.
So in this case, right, like expect the DDL to be in the form that the queries are given. How does it map between the DDL?
एक मिनट दे दे मेरे को और मैं ले लूंगी ब्रेड डाल दे इसमें टोस्टर में
Okay, guys. 1 second. See, answer your guys. One of you need to mute yourself. Okay. So the answer to that is it doesn't need to map. If it knows the DDL, it will understand the language. It will understand the schema. Are we together? Imagine a statement. A statement would be create table foo, create table produce, columns ID of int, name, varchar. You get the idea, right? That is it. SKU, blah, etc. What does that do? What does the AI do there? LLM looks at this table, looks at the name of the table, the columns, and it infers that this probably contains the produce info, isn't it? Then there is a table called orders or order items. What does that contain? Every transaction, which will be an intersection. It will say cabbages on this particular date at this particular time, 7 heads of cabbage, units of cabbage were bought by somebody. That's your transaction. Now, all that the machine needs to do, it says, okay, that's where I have the sale info. Here is the produce info. What do I need to do? It's a simple join from here to there, and I can get the answer, isn't it? I can aggregate over it to an order by total aggregate. And large language models are quite capable of, and remember, it is language understanding. It understands. It doesn't transform your schema into a SQL. It understands your schema and says, okay, now I know how to go about writing a SQL. You see that, right? That's the difference. That's why you often call this field natural language understanding.
So it assumes that the column names are meaningful.
It does assume, yeah, very good question. It assumes the column names are meaningful. And if it is not, it does. See, this field is imperfect. It is still evolving. Here is what I do in our world. If you were to like work in my team, when I used to lead a large team, so generally I was considered a very soft-spoken, kind person, broadly speaking, except on one thing, which trumped it all. Guess what that was? Code structure and code quality. You could not make a schema. You could not write a SQL query unless it was absolutely in a strict form with aliases and following a good convention and with comments and everything. We made sure that in the databases, we kept those comments and so forth. Right? So the more you do that, the more you assist the AI. Does that make sense? Right. And in this particular case, because we maintain the DDL externally in separate files with comments, guess what is the best thing to RAG? Directly the DDL with lots of our comments and headers, header comments and everything. Isn't it in SQL? So source code, guys, well-maintained source code. If you maintain your DDLs properly in well-written form, it's the laws of karma, Good karma bears great fruit. Right? And basically, then DML becomes free. Like querying the database becomes literally free after that. So are we getting it? The price you pay is you write very clean code with lots of comments, your data definitions. The benefit you get is almost all the queries are right all the time. Right? Go ahead.
2 days before there is a model called Star Coder 2 Instruct.
Oh, Star Coder 2 Instruct. This is from this company, right? What is this?
Yeah, Big Code.
Big Code, yeah.
Yeah, so they released a model to write a code in Python for the instruction.
Yeah.
So that is like available. So
oh, thank you. Could you share a link? I didn't know that the Star Coder 2 is out. I knew about Star Coder.
So.
Yeah. Please do drop that item on our Slack. Okay, guys. So this is what you need to do this afternoon. We'll break for lunch. Guys, are we clear on the project we have to do? Right. Let's end on that note. Today is the last day. It's an easy project, but you will see the power of the tools of the LLMs and where we are going with all of this. Right? So the other, so I know that some of you have questions, Prasanna. Why don't you ask your question, Prasanna? Go ahead.
Yeah, you said two things, right? Just run Vana and then do the actual project itself. Which one are you expecting
by end of today, just use one.
Okay.
Right? And after that, celebrate, talk, socialize, do whatever you want, have lunch.
Yeah.
But by get started with the larger project that I mentioned, which was do everything from scratch. What Vana has done, do it from scratch. Are we together? Yeah. Okay, guys. So that is
segment is just what you use the existing one, right?
Existing one, right? Do that. Also explore the data herald. So these are not simple projects. These are gaining a lot of attention, right? Play around with these. And SQL Coda has been one of the king of the hills. Default SQL Coda is very good, right? Play around with these tools, guys. For today, just play with the tools. Familiarize yourself with these tools. These are leading tools. Become good at it.
This is all about attention and everything across columns and trying to understand.
Yes. Right? It's amazing, guys. Do you realize that if you look back retrospectively, and I'll just do a quick retrospective on this course. Do you guys remember the first time you came and you saw the power of semantic search? Right? What a long journey. What a long journey we have come to in this course. This is it. This is the journey we did. Semantic search, transformers, we explained the transformers. We did attention is all you need. Streamlit, chainlit, approximate nearest neighbors. What was that? What were the tools we were using? Press. Yes. Promptly done, the CoStar framework. We learned about RAG, retrieval augmented generation. We did visual language understanding, CLIP. First of all, VIT, visual transformers. Then we learned about multimodal learning with CLIP, BLIP, BLIP2, Lava. You guys remember all that? We did some basic PyTorch project. We learned a little bit about ML Ops pipeline, the Ray framework, just enough to get started. We did visual embeddings and image captionings, etc. We did all of that. All of these tools, Jenkins, etc., you learned by doing the project. Spark, you learned by doing the project. You learnt about document AI and all the things in document AI. It was a big topic. We did a lot of things, many generations of it, from RC, fast RCNN, fast RCNN, faster RCNN, to altogether throwing away OCR with transformers, throwing away OCR altogether and going to pure multimodal transformer-based thinking with Donut. Do you remember that? Reading scientific documents, Nougat. We did some fine-tuning. Remember, we did some fine-tuning exercises. We did all of this. Then, some open source tools that you should use. We continued with a lot of this stuff, and we did segmentation. You remember, we started with old-fashioned segmentation using UNet. You remember? Followed by more modern segmentation, like SAM, grounded SAM, etc. Right? You all experimented with it. You saw the difference of it. We learned about diffusion models. Did we? Right? We learned the theory of diffusion. And I hope you played with the diffusion models. How many of you played with the Hugging Face diffusers of stable diffusion? You did. Very nice. So we have covered a lot of territory. A lot of you made presentations on the things that you cause diffusion models to generate. We did adversarial attack. Actually, I have to add that. How to protect your LLMs, right? The security aspect of it. And today we did the code generation. Now, I would like to end with the ethics part of AI, which is important, guys. AI is a powerful tool and it is capable of a great mischief. Much power, but much mischief. Then what is that, one of the comics or statement? In which character has that? With great power comes great responsibility. Spider-Man, right? Spider-Man. Yeah. Originally. Well, it's a foundation of jurisprudence. Right? At the foundation, the notion of justice is you get certain privileges. A society, see, there are no God-given rights. We say right to free speech. Many countries, it doesn't exist. Every society decides what its citizens have a right to, what they value. And the rights they give to their citizens reflects their value system. There are many countries that actually don't give you the right to free speech or curtail it severely. Every country curtails it. Some countries make a pretension that they don't. Right? But there is no such thing as free speech, just in the true sense, just as there is no such thing as true equality or democracy. If you think there's a democracy, next time you step into your office Monday morning and you get a lecture from your boss, think again. If there's true equality. So, well, every society comes up with its value system. But within the value system, with the things accessible to you, there is a responsibility. People say, I can drive a car. You have a privilege to drive a car. It's not a right. But there's a responsibility that you don't go creating accidents. The ethics is basically ethics question. And jurisprudence obviously tries to create law. I mean, the whole system tries to create a framework of law to keep you on, even on what would be the closest approximation to an ethical path. So same is true for AI, except that AI has great power. We have deep responsibility, but the framework of laws to create checks and balances don't exist, actually don't exist. There are forces that are opposing it. And on the other hand, there are forces that are so paranoid of AI that they would rather stop AI altogether. There are points of view that are extremes. Hard to tell, I suppose, but needless to say, our entire existence depends on taking individual responsibility when using AI, ethical responsibility, right? Or otherwise, trouble is afoot. Mischief is afoot. And to end with it, I'm always reminded every time people get too alarmed with the AI, I'm reminded with the Dickinsonian paragraph in The Tale of Two Cities. Anyone would like to tell me? And I would like to end this, our bootcamp with that. Anyone remembers that? It is a cliche, guys. Tale of Two Cities starts with Shruti.
I've not read that book.
You haven't read the book. Let me give you. It was the best of times. It was the worst of times. You remember the full passage?
Mhm.
Let me quote that passage to you. And, well, I want to read the full paragraph. I wish I'd brought my book. Okay, I will read the paragraph because I love this paragraph quite a bit. And okay, I think I can share my sound, but I'll let you read it in the voice of. Oh.
Hi, my name is Joanna Rodkey. I'm the former assistant director.
Those of you who are remote, can you hear it? The video?
Yes, we can hear it.
Okay.
Of the Dickens Project and currently president of the Friends of the Dickens Project. And for my selection for Dickens to Go, I'd like to read the first paragraph of chapter 1, The Period, from book the first, Recalled to Life, from A Tale of Two Cities. It was the best of times, it was the worst of times. It was the age of wisdom, it was the age of foolishness. It was the epoch of belief, it was the epoch of incredulity. It was the season of light, it was the season of darkness. It was the spring of hope, it was the winter of despair. We had everything before us, we had nothing before us. We were all going direct to heaven, we were all going direct the other way. In short, the period was so far like the present period that some of its noisiest authorities insisted on its being received for good or for evil in a superlative degree of comparison only. So I chose this because it just seems like it really applies to the time that we're going through now. It seems so applicable and is used so often by so many people.
I'll stop there, guys. So you realize that this was written at this story is about the French Revolution, long, long ago. Right? And yet you would agree that if you read the newspaper, this is exactly how it feels, isn't it? And the last point I like very much when it says, in short, the period was so far like the present period that some of its noisiest authorities insisted on its being received for good or for evil in the superlative degree of comparison only. AI is going to usher in the world of unprecedented prosperity and leisure on the one hand. AI is going to bring about the apocalypse. And so it has been. The topics change, the emotion remains the same. But AI, we do need to be very careful. With that, I'll end today, guys, our formal session. Please do your labs. We'll have presentations after lunch. And thank you all for being part of this journey. I really appreciated it. Being here, gotten to know each one of you, I feel quite fond of all of you. You know, it's one of the things in sitting where I sit. You end up becoming friends with everyone. And it's a bit nostalgic, this whole journey that we went through. And some sadness. It's a bit bittersweet to think that A, yes, you guys have learned what I hope you have learned what I wanted to teach you, but B, also, for some of you, this may be the last time meeting. So I wish you all the very best in your career, in your goals, in whatever you want to do. or the reasons that brought you to this course. And I hope you would stay in touch. Right.